Welcome back to InsureWright Insights. Last episode, we mapped the AI landscape, the trust deficit, the integration challenges, the gap between enterprise AI capabilities and mid-market need. We looked at how 80 of UK brokers haven't implemented AI, even though 42 say document extraction is their top need. We talked about the split between AI wrappers and evidence producer. Today, we're going to introduce the platform we've built to address those challenges, InsureWright. InsureWright is an evidence-first document extraction platform, purpose-built for commercial insurance underwriting. That description is carefully chosen. Not AI-powered, not an intelligent automation. Evidence first. Every word we extract, every field we identify, every decision the pipeline makes produces evidence, not just result. By the end of this episode, you'll understand what InsureWright does, how it works at a high level, and why we believe the insurance industry is ready for this approach. We'll cover the full feature set, the deployment flexibility, and cryptographic architecture that makes it all verifiable. Let's get into it. Let's start with the problem InsureWright solves. And I want to be specific here, because the problem is really well understood by anyone who's worked in commercial insurance. You're an underwriter. A submission package arrives. It's an email from a broker with 6 PDF attachments. An application form, 2 years of loss runs, a schedule of values for a commercial property portfolio, the insured's latest financial statements, a certificate from the expiring policy, and a cover letter. Maybe a few of those are scanned documents, not native PDFs, so the quality varies. Your job is to extract the key data, named insured, policy dates, limits, deductibles, addresses, industry codes, financial metric. Then you need to cross-reference. Does the application say the same policy period as the certificate? Does the named insured match across all documents? Are the limits consistent? Then, assess risk, check appetite, maybe screen for adverse news, calculate a premium, generate a quote, write a summary for your underwriting manager. That's hours of work per submission. For a complex multi-location commercial package, it can consume half a day or more. And here's the thing, it's highly skilled work. You need domain knowledge to know what matters, where to look, and what inconsistencies mean. But the mechanics, the actual reading, extracting, copying, and pasting, are repetitive, tedious, and prone to error. The Guidewire survey confirmed this. 42 of London market brokers cite submission intake and data extraction as their single most important AI use case. Not because the work is unskilled, because it's time-consuming, and because every manual extraction is a potential EO exposure. InsureWright automates that extraction, validation, conflict detection, and evidence assembly, while keeping you in control of every decision. You're not replaced. You're augmented with a system that reads documents faster and more completely than any human could, surfaces conflicts you might miss, and produces an audit trail that proves every extraction is correct. Here's what that looks like in practice. Drag and drop your submission documents onto the upload page. The system creates a submission, processes each document through a 15-stage pipeline, extracts 36 canonical fields, everything from named insured and company registration, number through to loss history and financial ratios, runs cross-document collision detection, attempts remediation for missing or low confidence fields, applies triage rules against your underwriting appetite, screens for adverse news, calculates rating, generates quote, options with recommendation rationale, produces an underwriting summary, and packages everything into a cryptographically sealed audit pack. All of that happens automatically. The pipeline runs into it. You review the results, resolve any collisions where documents disagree, and make your underwriting decision with every piece of evidence you need at your fingertip. The system makes you faster. You still make the decisions. Let me walk through the platform capabilities systematically. This is the full feature set as it exists today, and I want to be thorough because the details matter when you're evaluating extraction plan. First, multi-format ingestion. Ingestion. PDF, both native text and scanned images. Docs. XL, KXT. Pause. Automatic format detection. Out. You don't need to tell the system what kind of document you're uploading. It figures it out. This matters because in practice, submission packages come in every format imaginable. Some brokers send pristine, native, PDF. Others send photograph documents. Some embed data in spreadsheets. InsureWright handles them, all through the same pipeline. Second, multi-perspective extraction. This is a key differentiator. So let me explain what it means and why it matters. We don't rely on a single extraction engine. For native PDFs, both PDF Plumber and KimaDF extract in parallel to independent libraries, reading the same document and producing independent results. For scanned documents, our Hive OKR coordinator runs up to 5 OKR engines simultaneously. Tesseract, Paddlelocker, EasyOKR, Doctor, and Surya, and selects the best result by confidence score. The Hive coordinator is sophisticated. It doesn't just run engines and pick one. It applies quality adaptive preprocessing, high-quality scans, get minimal processing, low-quality scans get contrast enhancement, sharpening, and binarization. The preprocessing is tuned to the specific scan quality, not applied as a one-size-fits-all filter. Why does multi-perspective matter? Triangulation. When two engines agree on a word's text and bounding box, confidence is elevated. When they disagree, the system flags the discrepancy rather than silently choosing one answer. Think about what that means. Single-engine approaches fail silently. You get wrong results and don't know they're wrong. Multi-perspective approaches fail visibly, which means you catch problems before they become errors in your underwriting decisions. Third, 36-field canonical extraction. Named insured, company registration number, vet ID, policy period, start and end, limits, deductibles, premium information, contact details with phone and email, broker information, address, field, street, city, postcode, country, industry codes, financial metrics, and loss history. What? The complete set of fields an underwriter needs to assess a commercial submission. These aren't arbitrary choices. They map directly to the data points underwriters need on day one. We work through the underwriting workflow to identify what gets entered into every broker management system, what appears on every quote, what gets checked in every peer review. Fourth, word GPS provenance. This is where we get into evidence production, and it's arguably the most important capability to understand. Every word extracted from every document is assigned a unique GPS-like coordinate. The format is document hash, page number, paragraph index, sentence index, word index. Combined with the SHA-256 hash of the word itself, bounding box coordinates showing exactly where on the page the word appears, the confidence score from extraction. And a Merkle inclusion proof, this creates an unbreakable chain from any field value back to its exact physical location in the source document. A stakeholder can click any extracted field and trace it to the exact word on the exact page of the exact document with cryptographic proof that the word hasn't been altered. This is what we mean by evidence first. You don't have to trust us. You don't have to trust the AI. You can verify. Fifth, cross-document collision detection. When you upload multiple documents, an application, a certificate, a schedule of values, the system compares field values across all of them. If the application says the policy period starts January 1, and the certificate says February 1, that's a collision. Collisions are flagged by severity, trivial, minor, major, or critical. And you get a resolution workflow to decide which value is authoritative. This alone saves significant time and reduces EO exposure. How many underwriters have missed a discrepancy between an application and a certificate because they were reading documents in sequence rather than cross-comparing every field? Collision detection catches those conflicts automatically. Sixth, the remediation ladder. When fields are missing or have low confidence, the pipeline doesn't just shrug and move on. It runs through 5 remediation levels: long retries, rejects with relaxed patterns, and expanded search windows. L2 attempts extraction from alternative perspectives. L3 cross-references values found in other documents in the same submission. L4 uses an LN for intelligent field recovery budget capped at 10 cents per submission to control costs, and L5 escalates to human review with a clear explanation of what's missing and why automated recovery failed. The remediation ladder means higher extraction completeness without sacrificing quality. You get more fields filled, but every field still carries its provenance and confidence metadata. Now let's talk about what I believe truly sets InsureWright apart from everything else in the market: the court-grade audit pack. Every process submission produces a budget-compliant archive that serves as a self-contained evidence package. Let me explain what's in it, why each component matters, and why this matters for your business. Budget, first of all, is a specification from the Library of Congress for packaging digital content for reliable transfer and storage. It's used by institutions like the Smithsonian and the Library of Congress itself for digital preservation. We chose it because it's an open, well-understood, widely trusted standard for evidence packaging. Inside the audit pack, the SHA-256 manifest lists every file in the pack with its cryptographic hash. SHA-256 is a cryptographic hash function. It takes any input and produces a fixed-length fingerprint. If anyone modifies a single byte of any file after the pack is created, the hash changes, and tampering is immediately detectable. This isn't a subtle check, it's mathematically certain. The ED 25,519 digital signature proves the manifest hasn't been altered since it was created. ED 5,519 is a modern signing algorithm, fast, secure, and widely trusted in cryptographic application. It's the same family of algorithms used in SSH authentication and cryptocurrency protocols. The signature mathematically proves that the manifest you're looking at is the one that was originally created. The Merkle tree with inclusion proofs is where the architecture gets especially powerful. Every extracted word is a leaf in a Merkle tree. Imagine a pyramid. Individual word hashes at the bottom, paired and hashed together, going up, until you reach a single root hash at the top. That root hash is recorded in the manifest. What this means in practice: for any individual word, we can produce an inclusion proof, a path from that word's hash up to the root that proves the word was part of the original extract. You don't need the entire dataset to verify one specific word. If a regulator says, prove that the named insured was extracted correctly from page 3 of the application, you can produce a proof for that specific extraction, verified against the root hash in the manifest. Efficient. Targeted, mathematically certain. The RFC 3161 timestamp provides third-party proof of when the pack was created. We submit the manifest hash to a timestamp authority by default, freetsa.org. The TSA returns a signed token, proving the manifest existed at a specific time. This isn't our clock saying when the pack was made, it's an independent third party, cryptographically attesting to the timestamp. If there's ever a dispute about when an extraction was performed, the RFC 3161 token is admissible evidence. The tag manifest adds SHA-256 hashes of all tag files for budget completeness. This is part of the Library of Congress specification for ensuring nothing in the package has been tampered with. And then, there's the three-prong verification. The orchestrator runs a self-check. An independent precog verification runs. A post-verification manifest validation confirms everything is consistent. 3 independent checks that the pack is valid before it's sealed. But here's the part I really want you to understand. We provide a standalone verifier script. It's Python, using only standard library plus the NaCl cryptography package. It runs 8 independent checks against any audit pack. Baggage structure validity, manifest integrity, payload completeness, at 25,519 signature verification, Merkle root consistency, Merkle proof correctness, hash chain integrity. And RFC 3161 timestamp validation.out. All 8 checks pass in production. We have you all. And this is crucial. The verifier requires zero access to the InsureWright platform. Any third party, a regulator, an auditor, a reinsurer, a counterparty in a dispute can verify an audit pack independently. You don't have to trust us. You can verify yourself. That's what evidence first means. Let me address something that matters a lot to insurance buyers. Deployment flexibility and vendor independence. InsureWright runs entirely via Docker Compose with 4 services. The platform does not require a hosted SaaS model. That's a deliberate design decision. Fully local deployment runs on a single machine. All 5 OKR engines run locally. No external API calls are required for core extraction. Air gapped compatible. With LM remediation disabled and the timestamp authority set to mock mode, the system operates with zero internet connectivity. If you're in an environment where data cannot leave your infrastructure, and there are many insurance organizations where that's the requirement, InsureWright works. Your documents never leave your network. Your extractions happen on your hardware. Your audit packs are written to your file system. Optional. Today we use public LM calls, specifically OpenAI's GPT-4o Mini, for L4 remediation, which is the 4th level of the 5-level remediation lab. But that call is sandboxed to a single pipeline stage. It's budget capped at 10 cents per submission. It produces auditable traces, and it can be replaced with local models, private endpoints, or disabled entirely. The core extraction pipeline, stages 1 through 9, runs 100 locally, with 0 LM dependency. Cloud ready. The same Docker Compose stack deploys to AWS, Azure, GCP, or any container orchestrator. You choose where it runs. The architecture doesn't change. The audit packs don't change. The verification process doesn't change. This matters because the concerns we heard in episode 1, integration with existing systems, data sovereignty, trust in vendors, are all addressed by architecture, not by promises. You can run InsureWright on your infrastructure, with your data never leaving your network, using only deterministic extraction with no LM dependencies. Or you can run it in the cloud with all features enabled. The choice is yours, and the evidence quality is the same either way. Let's summarize what InsureWright offers. Multi-format document ingestion. Multi-perspective extraction with 7 independent engines across native and scan documents. 36 canonical field extraction, covering the complete underwriting intake, dataset. GPS provenance, tracing every word to its exact source location with cryptographic proof. Cross-document collision detection. A 5-level remediation ladder. Underwriting triage, adverse news screening, rating, and quote generation. And court-grade audit packs with cryptographic proofs that any third party can verify independently. This isn't AI that gives you answers. It's AI that gives you evidence. The difference matters when regulators ask how you derived a value. When EO claims arise and you need to prove what the document actually said. What did a document actually said? When a broker disputes an extraction and you need to show them exactly where the value came from. Evidence, not promises. Next episode we're going deep on market analysis. Where can InsureWright win? Who are the competitors? What's the strategic positioning? We'll walk through the SWOT analysis, the segment opportunities, and the white space where nobody's competing. If you're evaluating the competitive landscape, that's the episode for you. Thanks for listening to InsureWright Insights. See you next time. Adi.